let's go previous. So as I was saying, started off with this kind of CAD capability, all the sections drawn here extremely accurately, but in 3D modeling terms, and finite element analysis terms, structural analysis, this is unnecessary amounts of detail. It's the kind of detail that maybe you'd need to provide for the architects working with you, so they could understand where to place the ceilings and bits of wood that hide all this kind of structure. But in structural terms, it's kind of a bit over the top. So the idea is to kind of go through this setup of an absolute simple kind of wireframe that's showing really the volume of the structure, and then just the positions and lengths of the elements. And this is, in a way, this is the kind of level of detail that you need for your analysis models. It's just the center lines of the pieces of structure, and their lengths. Okay, but what I'll do is kind of show you three kind of advances from that. So there's a very kind of simplistic extrusion of the shapes. So these are called thicknesses, and that's extremely quick to generate, but it has its editability kind of problems. So where we need to do things a bit more accurately and kind of consider different angles and the like, then we kind of switch to what are called 3D faces. Okay, and a very quick to model, but way over the top in detail terms, are solid models. But it's knowing about these types of things and when to use them and when they're appropriate. So there may be situations where you need a solid element to do your analysis on. Other times it might be right back here just using simple lines. So this is the first thing I'll work through, and then what I'll also do is have a look at a kind of previous bit of student work and just go through input it. You can't see my cursor on the white background here, but I'm over on this kind of black and white drawing. So we'd put in the kind of the dimensional information in the black and white one, and then we can kind of move that into a kind of a 3D, a crude kind of 3D model where the elements are actually kind of sized. It wouldn't be a true kind of structure. We'll let things kind of collide a fair bit. It'll be fairly simplistic. Okay, so we'd start with this kind of 2D setup. We could color code it so that it represents the sizes of balsa or whatever it is you're using, and then we can flip that up, copy it by the width of the roadway for the bridge, put in floor beams, and then any kind of roof or bracing that's needed as well. Okay, and then next week or whenever we'll take that into 3D. So it's in wireframe at the moment, so it's kind of 3D, but it's not got this kind of solidity. So that'll be another kind of stage of that, fattening up these elements and dealing with the kind of gusset joints. You want to show where and how big these need to be for somebody else to make the model of it. So hopefully that's going to be give you food for thought on kind of the presentation and things that you might want to do. Hi, could you repeat that please? Sorry, I didn't hear that comment. Okay, let's crack on. Right, so what we'll do is we'll work on this one here, and firstly we'll do a little set out of the overall kind of structure. So what we'll say is it's a structural bay, 4 columns. It'll be 3 meters wide by 6 meters in the kind of upwards direction, in the Y direction. So I'm going to you'll notice I'm working in probably a different workspace than you've seen before. So down here in the bottom right hand corner there's a little cog icon, and a little arrow next to that you've got basically two different modes. Drafting and annotation is what was used for this drawing, whereas from here we need access to some more commands, and so we go to the 3D modeling workspace. Okay, so let's just repeat that. So this one's kind of got things like dimensions and a lot of stuff to do with text and things, whereas the 3D modeling, you can see we've got some extrusion, solid commands, and ways of editing solids and mesh surfaces, and all of this kind of terminology, very new to you today, but you know, that's one reason we kind of do this at this stage, kind of introduce the language of kind of 3D as well. Okay, so what I do is I park this so I can see a bit more of the commands as they get entered. Okay, and what I'm going to do is change this set out layer to a different color so it's a bit more visible on the online. Okay, so instead of blue, I'm going to make it orange. Okay, I'll leave it a different line type so we can just differentiate it from other stuff at just now, and I'll make that the current layer and close that. Okay, so all it needs initially is just a simple rectangle. So I'm not going to start anywhere specific, just alongside the stuff here. Okay, and then we tell it we want to go how far in the X direction and how far in the Y direction, and that gives you the opposite corner of the shape. So it's at 3000, 6000. Okay, so a bit bigger than the screen. And if I zoom in, you can see there is a broken line, but it's not very, the gaps and the dashes are too small for us to see. As we zoom out, we lose that definition. So the command to make the gaps a bit bigger is LTS, so it's short for line type scale, and I think a value of 10 should be sufficient. Okay, I'll use capitals so you can read the commands going in a bit easier. Okay, so first 3D operation is to view this from above, and we want to be, you know, generally from the side as well as directly above. So there's all sorts of ways you can do that. We've got these gizmos in the left, on the right hand side here. Okay, this is called a view cube. Doesn't look like a cube at the moment until you click a corner. So if I click this top corner, it should view the model from above at this side. So it's spun everything around, and we're now looking kind of diagonally towards that corner. Okay, so you've got all the different corners you can go to directly, and this is it's a kind of a hybrid isometric. It's not a true kind of 30 degree view. Okay, these give you the side views. They're not going to be show much at the moment because we haven't actually created anything vertically, but if I go to the front view, all you'll see is a lot of colour over this side and an orange line over here. Okay, so we're looking kind of at the edge of the model from the front. You can control this by just kind of dragging the corner, so we're kind of pivoting, and if you ever get lost in it, just come up to here and there's a little house icon, and that kind of resets it back to a kind of default view, which is kind of from the southwest. So that always gives you the same view, this one. Okay, another method of doing this is to use the orbit command from here. So you click orbit, you've got this kind of neutron looking cursor now. You use your left mouse button, and that gives you kind of free control. So this is really the kind of tool of choice, because it's good for kind of checking, you know, that things are lining up and you can kind of move things around freely. If you're using orbit, and you right click, you can change to a perspective view. It's not going to be very dramatic, but it is perspective now. Okay, it sometimes depends how close in you are, how much perspective gets kind of added. Okay, but generally we work in the parallel projection, and that's much better for telling when things are stacking properly. It's easier to see, you know, if you're moving vertically or downwards, whether things are in line with each other. And generally, you know, the buildings tend to be a stack of objects, so it is really important that things line up and down. Okay, if you want to go back to normal, okay, you type plan and enter twice. So I'll escape the orbit command, plan, enter twice, and that just kind of resets everything. Okay, you can do the orbit as well by holding shift and your middle mouse button, so that does the same. You know, with any 3D viewing command, you have to be careful. You know, if you've got a very, very complex model, you know, you have to give the graphics card chance to kind of get the model kind of floating and being able to be orientated. So most computers now, you know, can handle a reasonable 3D model. It's only when it gets really crazily big that you have to have, you know, dedicated graphics cards that have got a bit more power. But if you're using kind of wireframe type models, you know, they are no load on a machine at all. They're hardly anything. Okay, so what we'll do is we'll copy this rectangle upwards, and then we'll join the corners with our kind of beam, our column positions. Okay, so we haven't kind of used a proper 3D command yet. We've just used a kind of a viewing command. Next one's going to be copy, so that's no new command really. So I've got copy up here, or you can type CP in the command prompt. Okay, so I'll pick the edge of the object, enter. Now I've not got my ortho command on at the moment, so if I tried to move this vertically, okay, then I'm at risk of going off course. I could be anywhere. This will be kind of back in space. Okay, but if I hold shift, it brings on ortho temporarily. Okay, but if I were doing copies in 3D space, I'd make sure ortho was on before I started. Okay, so copy, enter. Base point can be anywhere because we know how far we've got to go. Okay, and you look carefully at your cursor and you can see it says ortho and then a number and then plus Z, and that's the direction that we're going in. Okay, if you drag, you see it changes to 180, so that's going sideways. 90, that's sliding backwards. But plus Z or minus Z, you're going up and down. Okay, so a plus Z, you don't have to, you know, get to 3000 and then try and click. You can just set the direction, let go of your mouse, and then type in 3000. Enter to stop. Okay, holding shift and middle mouse, just kind of look at that. It's like, well, it looks like they're on top of each other. You know, if in doubt, you check. So if we do plan now, we won't see two orange rectangles, we'll just see one because they should be directly above each other. So if I type plan, enter twice, it looks like there's only one rectangle there, but there's actually two. So just using the move command, it leaves one behind. So these are the things you have to do when you're working in 3D, is kind of check carefully that you can't see, you know, an extra shape. If there should only, you know, if they're identical, it should look like there's just one. Okay, so you'll notice that the icon over here is showing the Z coordinate, and this is called the UCS icon. So if you can control this, then you can basically kind of create any 3D model. So in AutoCAD it's called the UCS system. In Rhino, which is another 3D package that we use a lot, it's called construction planes, but it's exactly the same. Okay, so we can manipulate this by rotating about whichever axis we want. So we'd have to know the angles we want to move to do that, or you can use this drop down list to give you the kind of standard orthogonal directions. So the default direction is the world coordinate system. So it's like we're hovering over the ground and we're looking straight down. Okay, and when you're in the world coordinate system, the axis has a little square where the three of them meet. So that's the only time you see that little square. It's to tell you that you're kind of safe, you're back to the world coordinate system. Okay, if we wanted to work on this side of the model, that is the front. So when you click that, the axes change. So X is now running in this direction and Y is running this way. And Z is always in the kind of perpendicular to those two in those kind of terms. So Z is, if X is running this way and Y is running that way, Z will be coming this way. Okay, if X was running this way and Y was running that way, Z will be going this direction, which is the equivalent to the back UCS. Try that again. So X is running that way, Y is running this way. Okay, and if in doubt, you can type in UCS, enter twice, and it always goes back to the world coordinate system. So it kind of gets you out of trouble. I'll put a guide for this on My Dundee. If I just quickly show you, I wasn't sure. Dr. McCarthy might rearrange this a wee bit, but I just dropped in a folder to have these CAD stuff together. Okay, oh, that's strange. A little document I put on this morning isn't showing. Okay. But there's a little item here that discusses the UCS control, and it's where it's coming from. It's basically equivalent to the longitude and latitude system. Extremely useful in 2D. So just kind of goes through the various ways the commands get used. I've just explained this. If you get confused, UCS, enter twice, enter, enter. But it's when you get to 3D that it starts to really become extremely useful. So this is nice and clear. You can see that if we wanted to draw these rectangles on that sloping roof surface, then we need X to run this way and Y to run up the slope of the roof. And that puts us into the correct plane, and we basically just do 2D drawing work, but we're on a different work plane. Okay, so you can see a rough sketch showing that. Okay, and there's what I've found, the simple way of kind of getting your head around this is to use a left-hand rule, so that your pointing finger, your index finger, is the equivalent of the y-axis, your middle finger is the x-axis, and your thumb is the z-axis. So you can then kind of decide which way you need to manipulate the objects. And just a wee breakdown of the command panel, showing you the different ways you can control it. Really powerful. And if you're interested in 3D work and 3D modeling, then once you crack controlling the UCS, you're away. And that's just what it looks like in the Rhino software. So pretty much identical kind of control that you've got in that software as well. Okay, so that's what I'll do. I'll kind of put a few things will just kind of be like reference reads that you can follow up on if you want to. Okay, now at the moment this is a rectangle, which by default is actually a polyline. So it's a polyline that happens to be rectangular shaped. Okay, and they're not very kind of editable in 3D terms, not as editable as just normal lines. So what we'll do is explode both of those. So X, enter, pick them both and enter, and this then becomes a much more editable shape. So I'm just going to draw with normal lines. Okay, so a regular line. I've got object snaps available. Okay, I've got a few more on here than we really need, so I don't need tangent. Perpendicular is a tricky one to use in 3D, so I wouldn't generally use that. Intersection's okay. Node, we're not going to need that just now. We're not going to draw anything circular just yet, and midpoint's okay, so we'll just keep those three active. Okay, now don't get confused with these one. There is a 3D set of object snaps as well. These are really for working with point clouds, with like laser scan surveys. So I would leave these ones off. Okay, they're not really for the kind of 3D work that we're doing. So your normal object snaps will suffice. Okay, and the fewer the better with 3D. Quite often if I'm working in 3D I'll just use endpoint, because when the model gets reasonably complicated there can be just too many positions to accidentally pick on. Okay, so we're halfway through the line command here. It's saying where's the start point, where's the end point. Enter to stop. Ortho doesn't need to be on because we've got accurate positions to draw to. Okay, so I'll bring back the line command and just join these together. Okay, super simple. Now with a line we could draw diagonally through that object. Okay, now if I wanted to find the center of this object, then what I could do is change the UCS to be this side. Okay, let's go to the right hand side. I'll just draw a line down from middle to middle. Okay, middle to middle. Now in 3D terms that line cuts this one. Okay, when we look at it like this it doesn't, but if we look at it like that it does. Okay, and that's how the kind of 3D space works. It's operating in that plane. So if we trim, okay, take my cutting edge first, enter, and then you can see it's chopping that line halfway. If we do plan and enter twice, it's exactly halfway through that line. This line can trim this one. It's kind of a bit tricky to get your head around this, but we're working in that plane because we've changed the coordinate system. So everything you do is in this direction instead. So it's really useful. This is, being able to do 3D is extremely useful for working things out as well. And that's what I tell kind of students. CAD isn't just for presentation and things. It's your geometry control. It allows you to work things out. You and I know that the height of the end of that line will be 1500 because the overall height is 3000, isn't it? Okay, so if I asked it what is the coordinate at that end point, so I can do a command called ID, pick the end of that line, and it tells me that the y coordinate at that point is 1500 because that's the y coordinate is effectively the height in this view. Okay, so I'm just digressing a wee bit, but we want to kind of show you why 3D is so useful. It's not just for fancy graphics. It's for working stuff out. You're the lead designer of the structure of a building. People are going to ask you pretty tough questions down the line, saying, yeah, but I need to know how high that's going to be. I need to know the accurate length of this. Who else is going to work it out apart from you? So getting all these skills is extremely useful. Okay, so that's the kind of super basic volume that we want to work in. I'm going to go back to the world coordinate system, and I'm going to copy just the columns. Okay, so we'll take this to a kind of an analysis model next. I'm going to put ortho on, okay, and then we'll slide it to the side to do the next one. Okay, so this time we want to put the beams in at the beam center lines in the correct position. Okay, because this isn't actually the way things are operating. If we look at the drawing, yes, we've got the tops of the beams lining up, but their center lines don't, because we've got different sizes of beams. So the center line of this one is lower down than the center line of this one. Okay, so it's not necessarily about the tops of the bits of structure. So we've got set out as our command there. Let's just go to a plan view and zoom in so we can draw a few lines. Okay, I'm going to draw a line from the middle of that beam, okay, and just take it across so it's a bit easier to see. Okay, so that height is the height of the column. Okay, now I need a height for the middle of this beam, so I could use midpoint here. If I was in doubt, I would draw a line from the end of this to the bottom of that, and then pick up the midpoint. And what I want to do is take that to the center line of the column. So I could use extend, EX, pick a barrier, enter, pick the end of the line. Okay, so that's the center line of the small beam. So this is the 3 meter span. Okay, and now we're looking for the center line of the bigger beam. Okay, I'm going to switch off the solid fill layer there because it's not needed, and we don't need to see the dimensions either. So let's clear things up a bit. We don't need to see the holes either, so that's clear, make things a bit easier to work. So we're looking for the midpoint of the web of that beam. So let's find that, and we'll just take it out here a bit longer. But I do need to extend that a tiny bit, just by half the thickness of the web there. Okay, so these are our beam center lines that we need to transfer over to the model. Now we could use dimensions. We could say what's the distance between here and here, but whenever you handle numbers, there's always a chance that you transpose things wrongly, or you use the wrong. There's not enough decimal places, and it's therefore a little bit inaccurate. So generally, it's better to just move the geometry into position. Okay, so we'll do the small beam first. So we're going to pick it up by this point. Okay, because we do know the height of the column. Okay, so we'll pick it up, and then we'll change coordinate system, and then put it into position. Okay, so the command for that is Shift Control C. So it's Shift and Control at the same time, and then tap C. So you get a command called Copy Base. Okay, the base point is the middle of that top flange. It's the end of our setting outline there, but we pick up this line. Enter. Okay, now we go back into 3D. I go into that coordinate system, so it's the front Okay, and then do Shift Control V, and I'll have the line at the end of my cursor. And if I pick the top of my column, it's set the center line of the beam at the right height. So I'll explode that now. X, enter, pick the line, enter, because when you do the Shift Control C you're creating a block. I can't stretch it if it's a block. Okay, and then we can extend that over to here, so EX, pick the barrier, enter, pick near the end of the line. Okay, and then we can copy that from the top of the column to the top of this column. Okay, so we've got our two goalposts, and we need to go back to the world coordinate system to pick up the other beam center line. Okay, I'm going to do the Shift Control C without going back to the plan this time. So it's Shift Control C, same base point, pick a different line this time, enter. It's a different coordinate system I need now. I need either the right or the left. Let's use the left one, we haven't used that one yet. So I'm on the left side of the box. So X is running this way, Y is running that way. Then it's Shift Control V and put that on the top of the column. Okay, so the relationship is correct. The shorter beam is higher up than the longer beam. Explode that, and then I can extend it to this column. So EX, enter, pick the column, enter, extend the line. All we need to do now is copy that across to the other side. So copy, endpoint to endpoint. Now because that's actually a line, we could even offset it. Let's just see if that works. If I go back to the world coordinate system and use offset of 3000, it should end up on this side because it's still just a simple line. So offset is here, distance 3000, and there you go. So you've got that advantage of it being just simple lines that you can still use kind of 2D commands even though it's floating in midair now. Okay, so hopefully you understand the difference between those two. This little model's okay, but this is more accurate because the beam center lines are in the right positions, and and that's going to affect the structural reactions and things that you get, and the answers that come out of the system. Okay, right. What we'll do is we'll push on. We'll do a bit more on this, and then we'll have a wee 5-minute breather. Okay, so just let you know. So we'll do the next version of the model, and then we'll have a breather. Okay, so as you can see from here, we're starting to make things look a bit more kind of realistic. People might want to see what the structure is really going to look like. They probably can't envisage how things are going to come out by seeing just this. They might say, well, can we actually see that? How does it work? How high is a human in relation to this? Have we actually got clearances and things? Okay, so I've got a layer here called Shape Simple, so I'm going to create that layer in this drawing. Okay, on a new layer, Shape Simple. We'll use capitals. I thought I had capitals on. Okay, we'll make it yellow this time. Keep it the same as the example. I don't want it to be a dashed line though, so I'll change that to continuous and make it current. Okay, so it's a fairly similar methodology. So what I'll do is initially we'll just copy this setup because we need the kind of the center lines. So we'll copy this by the same distance. It's nice and tidy. Okay, so we can look at the shapes now, and we haven't dealt with the column yet, so this is where we need to pick up a shape for the column. So I'm just going to trace over the main kind of external edges of the column and a line across the middle as well. So that's all we need, just that H or I, depending on which way you'll be reading it. And then it's the same thing again, Shift Control C. This time we need the midpoint of the line we just drew. Pick those 3 lines and enter. Okay, come over to the model and Shift Control V. Okay, now we can't do much with it at the moment because it's still a block. If I hover, you can see it says block. So we need to explode that. Okay, and with these, what we can use is the change command. Okay, because we just change the property of those lines. So CH, enter. Okay, I'll pick up just those 3 lines, and you can see here we've got an option to change the thickness of the object. Okay, now we know the height for this, so we'll just plug that straight in, 6,000. Well, it's not 6,000, it's 3,000. 3,000 high, 6,000 wide, isn't it? So there we go, we've got something that looks structural. Okay, you just escape a couple of times to get rid of the grips. Okay, and then we can just copy that onto the other column setting out points. So copy, there's 3 items there, enter. We'll use the midpoint or the end point of the line there, and we just copy them around. Okay, I've got the columns in the right orientation, okay, because the short beam fixes to the flange of the column, whereas the long beam goes right into the web. Okay, so that's the same as we've got here. Okay, let's pick up the shape of the smaller beam next. Okay, so we want a... Oh no, we'll do the big beam, because the big beam is a constant length. Okay, so we'll do the big beam first. So just draw, we want to go, we're still in the world coordinate system, so that's okay for the tracing. So endpoint to endpoint, endpoint to endpoint, and then mid to mid. Okay, Shift Control C. Okay, we could use the top of the line, or we can use the middle because we've got the center line set up on the wireframe. So let's use the midpoint. Bear in mind you could use the top as well. Okay, so we'll go there, then pick the 3 objects, enter. Okay, but now we need the beam to go this direction. So we need to be in the front coordinate system or the back one. Either would be okay. So we'll use the front one. Okay, and we'll place the column, we'll place the beam at this end. So it's Shift Control V. So you see now it's facing the right way. We created it in the world one, but we're placing it in a different coordinate system. So it automatically takes on the new orientation. So use that endpoint. Okay, explode that. And then, because this is kind of paper thin structure, the length of that line is 6,000. So we can use that with the change command. Okay, so we could put in 6,000 at this point here. Okay, and it's going to come towards us. If we use minus 6,000, it will go back this way. Okay, if I just show you that, say minus 6,000, it jumps to the other direction. Okay, because positive Z is coming out of the screen towards us. Okay, so we want positive 6,000, enter to finish. escape to get rid of the grips, and then we can copy that over to the other side. Copy. Okay, we've got all sorts of base points we could use for the copy here. We could use the end point here to end point. We could use the end of the center line to the end of the center line. You know, we're drawing things carefully and consistently, so there's all sorts of options. We could use the end point here to end point here. Midpoint is exactly the same, it's just as accurate. Okay, it's taking shape. You can test this now. You can use one of the shading options, the visual styles. Okay, I generally would use this one, shaded with edges. Sometimes X-ray is useful if you kind of want to see kind of 50% kind of transparency. Okay, but generally I would test it by looking at shaded with edges so I can see where everything is, and then spin it round just to make sure things are sitting correctly. But then go back to 2D wireframe. Okay, this wireframe is still considered a shaded view. It pretty much looks exactly the same as 2D wireframe, but you know, as far as the graphics card concerns, it's a shaded option. So 2D wireframe, the lines do look a bit cleaner. Okay, the short beams are the tricky ones because they're not 3 meters long. The short beams go from end to end, so we have to take a little bit of a different approach. So we can't use this change command this time because we don't know what the actual length is from here to here. Okay, so we'll get the shape, so we go back to the world coordinate system, get the shape of the beam, so we'll draw the 2D shape just roughly. Okay, we'll do our same copy and paste, so we'll use the middle as the setting out point, Shift Control C, base point, pick the 3 items, enter, and then we go up to here, but we now, what I'll do is place it at this end, but because it's facing in this direction we need to use the right coordinate system. Okay, Shift Control V. Okay, so our beam is going to be running in that direction. Okay, now my base point that I chose is a bit problematic because I'm placing the beam in the wrong place. Okay, so let's just run with it, put it there, but what I need to do is now move it from that point to this point so that it's sitting on the face of the flange. So it's move, I'll pick the shape, enter, and I'll go from midpoint or intersection or end point, all 3 of them are the same, to this midpoint or end point. Okay, so that's the shape we've just added. Okay, we explode that, so X, enter. Okay, we're going to use the change command, but using it from the keyboard instead, and that gives us an option to change the thickness by picking on screen. When you use this panel, you can't pick the distance you want to use. Okay, but if you use -CH, okay, that forces the command to stay in the command prompt. So the minus makes the command stay down here. So select the objects, 1, 2, 3, enter. We want to change a property. We want to change thickness. But now it lets us pick the thickness. We could type it in, but I don't know the number, but we can choose the distance we want. So it's from here to here. Enter, and enter to finish. Okay, so thickness is a property of an object, so it can be matched. So if I just show you, we don't have the match properties command sitting pretty here, so I just used MA for match properties. So if I pick this and then pick this, it will shorten this line. You see, it's a property, so it can be applied to other objects. So this is one advantage of using these thicknesses, that you can do things quite quickly like that. So we can shorten, do all sorts of things. Okay, looking good. Just a final copy. So there's 3 items to copy across, and we've got all sorts of base points we could use. I think I'll use some that are pretty easy to get, so I'm going to go from corner here to corner here. So you just have to be consistent. You know, if these were different size columns, that would be risky, but then they're all the same size. Okay, so that's our what would you call it, kind of thickness version, which, you know, certainly gives you a better idea of what's happening. So you can kind of understand your structure much better, but you've not done too much work, and it's not too much effort to get to that stage. But certainly more, you know, visual and understandable than a model like this, which is really more for the analysis software. Okay, I'm just going to save it at that point. I haven't saved so far, so I'll do a save as, and let's call this 3D model halfway. Model halfway. Oops. That'll do. Okay, my caps lock's confused, and I'm just going to stop the video at that point.